Hey everybody. Earlier this week, whenever I posted the assignment to take a look at MakerCAM, I think I mentioned to you that I was going to go through the tutorial that was on that website with you and sort of guide everybody through the process. I know that we've kind of gotten off to a pretty rough start, and so I just want to make sure everybody makes it through this first assignment really comfortably without any problems at all. As I mentioned, this is a web page, and so everybody should be able to get to it from some kind of computer. So whenever you're ready to go, just go to a web browser and click in www.makercam.com. It's a really simple piece of software, a really simple website application on a website. Loads up really fast. It's really straightforward, and so shouldn't present any problems, but feel free to let me know if it does. First thing that you need to do, you'll notice that there's a grid pattern on the screen. Well, you need to be able to see the origin. That's the spot where the X and Y axes meet, and so what we're going to do is zoom out, and I just had to click it one time and it showed me where the origin is at. I may even click one more time. But here's the origin. Here's where X is 0 and Y is 0. So we're going to go ahead and proceed. I mentioned to you that there was a tutorial available on the site, and so you can come up to the right hand side of the screen and click tutorial, and it gives you all the details step by step to go through the whole process and create some G-code or create some machine programs based on the drawing that you do on the website. So I've made a copy of this. I've laid it off to the side, and I'm going to be referring to it, and I'm going to let you guys see the screenshot as I work my way through it. So here we go. All right. First thing that they ask you to do is to insert a rounded rectangle, and they want you to make it 3.5 by 3.5. So I'm going to type in 3.5 in both places, and we're going to leave the corner radius at 0.2 of an inch, 0.2 inches. So we're going to click OK, and there's our rectangle. Next thing we need to do is drag it down to the corner where and kind of tuck it back here next to the origin. So I'm going to select the arrow tool there, and I'm going to select their rectangle, and I'm going to move it down, and I'm just going to place it right here really carefully right there in the corner. Alright, and then they've asked us to just insert another rectangle. Excuse me, no, I'm going to back out of that. Insert another rounded rectangle, and this time instead of 3.5 inches, we want to make it 3 1/8 or 3.125 inches. So we're going to make it 3.125 and 3.125. And again, we're going to leave the quarter radius at 0.2 of an inch. Alright, we'll do the same thing. Come up here, grab an arrow, select that. Oop, sorry. We'll bring it down, tuck it in just right in there so that it's nice and even all the way around. And let's see. I'm going to click and leave it. Whoop. Well, click and leave it there. Well, I'm having trouble leaving it there. It's kind of sticking to my arrow. So let's try that again. I'm going to select it, and I'm going to drag it down, and I'm going to turn loose of it. Actually, it needs to be moved just a little tad more. I didn't get exactly even. So I'm going to leave it about right there. That looks better. Alright, and so what we've got then is just one large rectangle with a smaller rectangle inside of it. And what they're asking you to do for the third item that you're going to draw on the screen, actually I'm going to zoom this in a little bit more and see if we can't actually what I'm doing right here, and I hope you guys are able to do it, is I've come down here, and with the middle mouse wheel I'm just rolling it around so that I can kind of blow it up a little, maneuver it around on the screen and get it positioned good there. But at any rate, the next thing that they want you to put on the screen is to use the pencil tool up here. And so we're just going to be drawing lines, and they want you to draw in block letters your first letter of your last name. So you can choose any letter you want to, it doesn't matter. You can even choose any other shape if you want to. My last name starts with a D, so I'm going to try to draw a D here. And it's a little wonky, so you're going to have to do some tinkering with it. And I'm going to try to draw a D using only straight lines, and that's a little bit tough. Alright, so I've got a D drawn there, and if we were to zoom into that, what we'd see is that a lot of those segments, like right here, don't even touch one another. And here these overlap. That's kind of ugly. One of the things in CAM systems that you're going to find out is that whenever lines like that don't intersect, it can cause some issues. So what I'd like to do is choose a different tool up here. This is the arrow with a little circle on the end, and what that means is that you're going to be editing some endpoints. So we're going to pull this up, and we're going to mouse over that endpoint there, and you'll see a little red dot comes up. And when the red dot comes up, just click and hold on it, and it will automatically, if you move it around there enough and get it close enough, it will snap to that endpoint. So now we've closed in that. Let's try closing in this. Whoop, that did it fast, didn't it? So then we'll come down here, same thing there. Alright, and let's look at all the corners and make sure looks like that one's good and tight. Whoop. And that corner's good and tight, that corner's good and connected together. So looks like everything's good, and I have sort of an ugly D. But one thing that we can do to select, one way that we can select the whole thing, we can try doing it just this way. Actually, that worked pretty well. We can also just drag down across the whole thing and select it. And once we get all the corners connected and it's a complete circle with no gaps, then it becomes one object in the drawing. So we can move it around, and you'll want to take your letter and position it inside the middle of the rectangle. Now, if you have some trouble later on with whatever letter you happen to choose, not all letters are alike, in that this D is sort of enclosed, and you may find that you need to switch off to some other shape. Maybe you can insert a star and a polygon and some other things. So if you want to do that instead of a letter, that's okay with me too. What we're trying to do is create an enclosed shape that we can do some pocket milling in there. So that is essentially all the drawing that we have to do on this part. So now we're about ready to start telling the machine how to do pocket milling. In order to create our first machining operation, we have to select one of these objects. And we'll just go ahead and select the D in my case. It might be a different object in your case, a different letter. It could be a star, anything that you happen to want to place in the middle of this coaster that we're building here. And once it's selected, we can come up to the CAM option and say that we want to do a pocket operation. All right, so what a pocket operation is that we're going to come in here from above with an end mill. Think of it as a Dremel tool bit. In the case of CNC machines, it's a Dremel tool bit on steroids. But anyway, we're going to come in here and we're going to eat down in this area a little deeper than the surrounding surface is. So we're going to create a pocket inside this outside perimeter. And what they've suggested that we do here is that we relabel that and call it letter pocket. All right, and we're going to use a 1/8 inch end mill, and we're going to make the depth of that pocket minus 0.03125. Now what the minus means is that we're going to be going down below the surface. So minus in CNC machining, in CAM, typically means that you're down below the surface of the material. So we're going to create a pocket with an 1/8 inch tool that's 0.031, or about 31 thousandths deep. So we've got that in there. The next thing is our safety height. We're going to use 0.25. Now what that means is that when the tool comes in here and eats out this material, or machines out this material, and gets ready to go to another operation, it's going to come up out of the pocket 1/4 of an inch so that it's clear of the top surface. Then it can go over to these other operations and do them. So just something to be aware of there. What we're telling it here is that the stock surface is at 0. Here we're talking about step over. They are recommending in this tutorial a step over of 40%. And what that means is that the tool will start out here, and as it goes in a bigger and bigger loop, it's going to step over 40% the width of the tool as it goes. And you'll see whenever we get our tool paths created what that looks like. So stock surface at 0, step over 40%, step down. We've got the option of going to the full depth in different steps. In other words, we could go let's say we go 10 thousandths deep on the first pass, and then we go down to 20 thousandths on the second pass, and we go to 30 thousandths on the third pass. Well, then in that case we would be going down 10 thousandths at a time. But what the tutorial is suggesting is that we go the complete 3125, or 0.03125. That's 31.2 thousandths. So 0.03125. Okay, so we're going to go down the whole amount the first time. We're going to make one pass at it, and it's going to take the entire depth out of that pocket. Roughing clearance, we don't have to worry about that. We're going to let the machine go right up to the edge. We're not going to leave any material left over to come back and clean up later. All right, feed rate is going to be 30 inches per minute. All right, and that just tells the machine how fast you want the tool to move around here. How fast do we want that to go? Plunge rate, that's how fast the tool is going to plunge in to that area. How fast the tool goes into the material from above, and how fast that it comes out of the material after the cut's done. All right, and they are suggesting that we circle around here and mill this material out in a counterclockwise fashion, so we'll be going like this. All right, so we're going to choose counterclockwise, and we'll say OK. All right, now you'll notice that there's a hatch pattern that's shown up inside my D. With this website, I noticed that even though it may not show the hash marks or the hatching around the full perimeter, or inside the full perimeter, it's still using the full perimeter in order to do the machining calculations. So don't get discouraged if you don't see hatching over the entire area in there. That takes care of the machining operation for the D in the middle. The next thing they ask you to do is select the inside rounded rectangle. All right, and so we're going to select that one. It's highlighted red now, and we're going to go in it, and we want to tell the software, we're going to come up here to CAM, and we're going to tell it to follow a path. What that means is that the tool's just going to come in, and it's going to cut right along that path all the way around, and it's going to make a groove 1/8 inch wide, same width as the tool. So we're going to call that trim and grave. Okay, and we're going to use, as I mentioned, an 1/8 inch diameter tool, and the target depth on this is going to be exactly the same as our pocket was. It's going to be minus 0.03125, and our safety height is going to be 1/4 inch again, so that when the tool comes up out of the material and goes from one location to the other, it's 1/4 inch above the top so that we don't hit anything. Stock surface, again, is at 0. The step down, again, we're going to take the entire depth and cut it in one pass all the way around. We're not going to make one light pass and then come in and go deeper and make a heavier pass. We're going to cut it all in one pass. So our step down is the full 0.3125. Okay, sorry for the interruption. My cell phone rang. What we were talking about was the step down, and we're going to go put an extra 0 in there, so we'll take that out. What we're going to do is go around the entire outside edge at the full depth of 0.03125 in one pass, so that we only have to make one pass. And the end mill can handle 31 thousandths, no problem. That's not very deep. Our feed rate is going to be 30 inches per minute, and our plunge rate into and out of the cut is going to be 10 inches per minute. That's just the 30 inches per minute is how fast the tool moves around here, and the 10 inches a minute is how fast it plunges into and out of the cut. So we'll say OK, and that creates another tool path, and you'll see that it's highlighted in yellow because it the 1/8 inch tool just follows that contour around the outside edge there. Okay, and so the third tool path, or the third machining operation that we want to look at, we want to select the outside circle, and we're going to go up here to CAM, and we're going to call this a profile operation. All right, and we're going to name it coaster cutout. All right, and what they're recommended for coaster cutout is, again, we're going to use the same 1/8 inch tool, and we're going to use the same, actually we're not going to use the same depth. We're going to use 1/4 inch deep, which is quite a bit further down. We're going to do minus 0.26. So if we had 1/4 inch thick material, that would go all the way through and cut out on the outside. And we're going to cut on the outside, and the safety height, again, that's the height above so that we are clear when we cross, is going to be 1/4 inch again. 0.25, and the stock surface is at 0, and the step down this time is going to be 0.03125. And what that means is that we're going to take several passes around the outside in order to get down to that full depth of 0.26 inches. So however many times you've got to go down 31 thousandths to get 0.26, that's the number of trips we'll make around the outside edge. Our feed rate is going to be excuse me, I skipped one here. Step down 0.03125. Feed rate is going to be 30, and our plunge rate is going to be 10, and we're going to go clockwise. Okay, so we'll say okay. Okay, so now we've got all three operations defined, and we can go up here and click on View Cuts, and it'll show us what's going to happen here. So we've got hatch pattern in here. We've got we're following a path here. We've got an 1/8 inch area around the end mill that's going to be cut out, or a groove that's going to be cut into the material, and then we're going to be cutting around the outside edge of this part, and the inside material is what's going to be kept. Alright, so now we're ready to generate our G-code. That's the instructions that tell the machine how to make all those cuts. So let's go to CAM, and let's go to calculate all. At least I think it's calculate all. Click CAM, calculate all. Alright, so you can see in red where that tool's going to go. It's going to start here and keep working its way out, 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 and it's going to get as far out as it can go, and trim out or create a pocket inside that letter. You'll notice up here in the corners that it can't get in because an 1/8 inch tool cannot get into a sharp corner like that. It's too big. So it just has to leave that one out, and it just steers clear of that. In this particular case, it's going to follow that line all the way around, and it's going to cut out an equal amount of material on each side of that line. So the center of the cutter is going to follow that line, and it's going to cut out an 1/8 inch wide area, 1/16 on either side. And then on the outside rectangle, what has happened is that as we rotate around this, as we work our way around this line or this rectangle, the cutter is actually going to be working on the outside and cutting through the material and leaving just what's inside that line. So the area in pink there is the material that the cutter is going to be removing, and it's outside the rectangle, so it's going to be out here in the throwaway part of the stock. So now you have tool paths that are ready to go. We've drawn something up in CAM. We've told it what we want to cut, and now it understands, and it's telling us with some shading here what it's planning to do. And if we're okay with that, and I think it looks great, then we're going to be able to export the G-code now. And so what we need to do is come back up to CAM again. Lots going on in that one menu option there, and say export G-code. It's going to ask us some questions. It wants to make sure letter pocket is first, trim engrave is second, and coaster cutout is third. And if we're ready to go with all of those, we could select any one of those and create the G-code. But we want to do them all at one time. So let's click all. It'll select every one of those operations, and we're going to say export selected toolpath, and we're going to export it as standard G-code. So let's export that rascal. Alright, so it brings a window up and wants to know where we want it sent to. I always send my stuff to the desktop. I know a lot of you make fun of me because I have so many icons on my desktop, but what we're going to call this, per the suggestion in the tutorial, is we're going to call it monogram coaster .nc. Now, as you go further in the CAM, that .nc is going to be more and more important, because NC stands for numerical control file, and really all it means is that it's a certain type of file. It's all text, and it is used to control machines that accept G-code, which is the vast majority of CNC machines these days. So if you're able to write G-code and save it as an NC file, you can use that file on a whole lot of CNC machines. So we're just going to save that to the desktop, and it's still this website, this app leaves this all sitting here, and it's really not necessary because it did save it, even though it didn't give us a confirmation, and even though it didn't close out that window. So we can close this just temporarily, and we can come and look, see if we can find their see if we can find our oh shucks, where is there? monogram.nc. Let me try this again. I'm not sure it's okay. Sorry about that. I just overlooked it. It's right here in this area, and so I'm going to double click on that, and you're going to get to see what a G-code file looks like, or an NC file written in G-code. Alright, and so you can see all the instructions that are going to be used to run that machine. And it's kind of interesting, all the students who take CNC classes here start by writing the code by hand, and we start with simple programs and then gradually progress until we get into more complicated ones. And I don't think that this is one that you'd want to write by hand. It's pretty tedious, so there's a lot of lines of code there, and you'll notice that they all start with a G. That's why they call it G-code. And so this is the file that will load into the CNC machine that will actually cut that out. So, and it's also the file that you'll submit for your assignment for this project. So I hope this helps some, and let me know if you have any more questions by email or give me a call. I'll be glad to help out. So see if you can get your coaster G-code done, and send me the file. Thanks a lot. Bye.